Thank you, everyone, for joining us on the Cloud Native FM podcast. And today we are talking about Tekton and supply chain security. And talking about supply chain security, why not we talk about Chain Guard? And Chain Guard team has been an inventor of these so many good, awesome tools like Cosine, Rigor, Fulcio, Tekton, and there are so many other. And I'm privileged today. I have a guest from the Chain Guard team. He's been an actively member of this some of the wonderful tool that we are using in the supply chain security. That is Priya Wadhwa. I hope I pronounce your name correctly.
Yeah,
Thank you for joining me today, Priya.
thank you for having me. I'm so excited to be here.
And before we dive into the tech tone and supply chain security, talk us about yourself, about your journey being into the cloud native and in the supply chain security.
Definitely. So before ChainGuard, I worked at Google for almost 5 years. When I started at Google, I started on an open source team that worked on Kubernetes developer tools. So if you heard of like Minikube or Scaffold, I spent a few years working on those tools. So I was really lucky to kind of always be in open source, like kind of my entire career. Because I've always really enjoyed like working with the community and getting to meet other people and kind of collaborate with a lot of people. So I was always in open source, and eventually like I started kind of working with the Tekton project a little bit, but not too much. And then early last year, I think you have had Dan on your show before. He started an open source security team at Google. And so I joined his team, and that's kind of when I was introduced to this world of security. I never really worked in security before, but really quickly it like hit me how important of a topic it is, and like how it's become increasingly important in the past couple of years. Um, and so my work really focused on supply chain security when I was on that team, looking at tools like Sigstore and working on tools like Tekton chains, which I'm going to be talking about later. So I did that for a good portion of last year. And then when ChainGuard kind of started, I felt like there were just so many cool people joining. I thought I would learn a lot. The mission was like really valuable to me. So I joined ChainGuard in January, and yeah, have pretty much been working on the same projects like Sigstore and Tekton ever since.
Absolutely, absolutely. I think the supply security has been the past is a very, very complicated topic, and you
Mhm.
try to stay away from that conversation because it's really complex. Because container, then the cloud, and then it's a cluster, and then the Kubernetes. So there is so many moving pieces into it. But now, with the thanks to the tool like Cosine and TektonCD and other, they really make security very easy for us. And hope you have a wonderful demo and wonderful things to share with us. So feel free to share your screen and to start talking about the Tekton and the
Sure.
project.
So let me share my screen. So I'll kind of just talk about like what Tekton is really quickly before I dive into it. So Tekton is an open source CI/CD platform that's built on top of Kubernetes. So it's an open source project. It'll run on any Kubernetes cluster. So regardless of what cloud provider you're using, you can kind of use Tekton for all of your CI/CD needs. Anything that you would kind of normally do in a CI/CD platform, build artifacts, run tests, deploy things, you can do all of that from Tekton. And I'll definitely go into like kind of the details more in this demo. But first, I started by just creating an EKS cluster. I already did it because it takes a few minutes to spin up, and I didn't want people to be bored while they waited around for it. But I used this command line tool, EKSCTL, to create the cluster. A few things of note, I just named it after myself, apparently. So a version for Kubernetes with one node, and the key flag that I have passed in here is with OIDC, which I won't talk about too much right now, but it will come up later. So the next thing I did, which I also already did, but I'll just show the commands for now, I installed Tekton pipelines. So we can actually maybe take a look at the Tekton code later, but it's a really easy to apply Tekton pipelines, which is kind of the core Tekton project. Just one like who control apply command, and then we're going to be installing version 0.32. So I already ran this, so it shouldn't actually take too long. I don't think any of this stuff should change, but it installs a bunch of cluster roles, role bindings, a mutating webhook to validate like config, task run configs, and Tekton configs, and just some like config maps, which you can use to kind of change different or set up different features if you want to. But the main thing that we have is we have this Tekton pipelines namespace that is created, and we have a controller running. So this controller is basically responsible for turning your Tekton config into actionable Kubernetes objects like pods. So if we go into the first part of this demo, so the basic unit of Tekton is a Tekton task, and a task can you can kind of think of a task as one step in your build pipeline. So if this task kind of looks similar to like a Kubernetes pod spec to you, that's because the Tekton controller is basically responsible for turning the task into a pod so that it can actually run on Kubernetes. So they do have a lot of similarities. But this is a really basic task. All it does is it's got one step, takes an Ubuntu image and prints hello world. So it's pretty simple, and you can apply it to your test cluster just with a like standard kubectl apply command. So we've created this Tekton task. So creating the task itself doesn't actually do anything, because the task is, you can think of it just as like a building block in a larger pipeline. Tekton requires that you set up something called a task run to actually instantiate the task and like kick off the build. So we have this spec for a task run, which will basically just generate some task run with a name that starts with this, and then it references the task that we just applied to the cluster. So when we kick off this task run, the controller will basically pick it up and be like, oh, I need to start a build. What am I supposed to build? It'll look for a task in the cluster with the name hello, which it should find because we just created that, and it should kick off the run. So if you do a kubectl create on this, the task run has been created. So if we do a kubectl get task run, we should see that the task run is created and it's running. So under the hood, the Tekton controller has taken this task run and created a pod out of it. So if we look for pods, we can see that this is like the associated pod for the task run, and it already completed executing. So that's great. I like to use this TKN tool, which is kind of a Tekton CLI tool that makes it really easy to kind of get information about the task runs in your cluster. So we can do a TKN task run describe on the task run that we just created, and it'll kind of provide you with some like details. This one is a really simple task run, so a lot of these fields are blank, but it'll say that there was one step called hello and it was completed. And we can also look at the logs for this task run, and oops, wrong order. There we go. And we can see that it printed out hello world just like we expected. So moving on to another kind of Tekton concept. So now that we've seen tasks, we can take a look at pipelines. So before I do this, I'm going to kick off one more task. So this one's going to be called a goodbye task. So we can do the same thing that we did earlier and just apply this task to the cluster. This one is basically doing the same thing as the hello world task, except this time we're just passing in a bash script, and it's just going to print goodbye world. So we've created the task. Now we can create the cluster associated with the task. It's supposed to be a create. And we can take a look at the logs for this one as well. And we see goodbye world, kind of just as we expected. So nothing too interesting there, but now we can take a look at this kind of another core Tekton concept called a pipeline. So a pipeline is basically a way to string a bunch of tasks together. So if each task kind of the idea is that each task is organizationally responsible for doing one thing, and then the pipeline will string it together in some sort of order. And you can like specify that you want tasks to run in some kind of order. So here, first we'll be running the hello task, which references hello. And then after that, we will be running the goodbye task, but we have indicated that we want it to run after hello so that we know that hello will be executed first. So just as we did with the task, we'll apply the pipeline here, and it should be created in the cluster. And we also need to instantiate the pipeline with a pipeline run. So I have a really similar looking pipeline run definition, which references this pipeline that we just created. So if we do kubectl create on this pipeline run, we should see some things start to happen. So if we do, we can get a list of all the pipeline runs, and we should see that the one that we just set up is running. If we look under the hood and take a look at the pods, you can see that we have 2 pods associated with the hello goodbye pipeline. The first one runs the hello task, and then the second one is going to run the goodbye task. And this is still initializing because it's waiting for this one to complete, or it was at the time that I ran the command. This should probably be done by now. So we can use the Tekton TKN CLI tool to take a look at the logs for this pipeline run, and we should see hello, and then we should see goodbye. And the output is kind of nice because it'll also tell you which task these kind of came from. So this is great and all, but obviously these are pretty simple, not very realistic pipelines or tasks that you might actually want to run. So I'll dive into kind of a more complicated one now. So before I get into this, I want to talk about Tekton Chains a little bit, which is one of the open source projects that I work on. So the idea behind Tekton Chains is that it is the supply chain security manager for Tekton. So you can see that with Tekton, you can kind of run your builds. We didn't do it in kind of the basic examples, but we will be building an image, an OCI image, pushing it to a registry. You can build any kind of artifact and store it wherever you need to. And the responsibility of Tekton Chains is once that build is complete, it'll take care of anything related to security around your supply chain that you might want to do. So it can do things like sign your images or sign your artifacts. It can generate signed provenance and store that in any kind of backend, whether that is like an OCI registry or a transparency log. And Tekton Chains also supports signing in a bunch of different methods. So you can set up your own public-private key pair. You can do keyless signing with full CO, which is the Sigstore certificate authority. And that's what we're going to do in this part of the demo. So the first thing I'm going to need to do is install Tekton Chains. And I've already done this, but it's also just another kubectl apply command, similar to Tekton pipelines, except now we're installing Tekton Chains. So nothing should be different. What we're going to want to do is we're going to kick off this task. So it's a slightly more complicated task than the ones we were running earlier. Let's just take a look at it. So this task runs Canico, which is a tool to build OCI images from a Docker file in your Kubernetes cluster. So this task, so we have a little task description, which will kind of explain what it does. We have a few parameters that will need to be set. So the name of the image that we want to build and push to registry, a path to the Docker file that we want to build, and which Canico image we want to use to do the build. So we've pinned it to version 1.5.1. There's a couple workspaces here. So workspaces are, you can kind of think of them as like how volumes would be in Kubernetes. You can use workspaces to mount in specific files or file systems somewhere in your task so that your task has access to them. So in this task, we require 2 workspaces to be defined. So the first one is called source. That one is going to be where the Docker file that we're trying to build lives. And the second one is called Docker config. So this one is optional. It's only required if you need to set up authentication to push the final image to an OCI registry. So we will be doing this because we will be pushing the image to my private ECR repository. And then Tekton also has this concept of results. So once a task is done, a result is, you can think of it as kind of an output from the task. So once this task is done, we expect an image to have been built, and the result of this task will be the digest of that image and the URL, or like the name of the repository where that image was stored. The cool thing about results is that they can actually, if we were to hook this up in a pipeline and run some sort of task after this, we can pass these results to tasks that happen later in the pipeline. So this information can be used later on, which is kind of cool. So let's get into the steps. What is this task actually doing? So the first thing, I just kind of took an easy way about adding in a Docker file into this task. I just kind of have a step in here, which will first add the Docker file. The working directory is the workspaces, is a source workspace where we expect the Docker file to live. And I just have this really simple script, which is just kind of creating a Docker file off the cuff and storing some commands in wherever we expect the Docker file to exist. The second step is where kind of everything happens with Canico, where we build and push the final image. So we are running again in the source workspace where we expect the Docker file to live, building with the Canico image that was specified in the parameters above, and passing in a bunch of information like where the Docker file is and where we want the image to be pushed when the image is pushed. The final step basically will just store the URL of the image, or like kind of the destination of the image in the actual results file. And this is kind of, this is necessary because we need some way of telling Tekton chains what image we built. And so Tekton chains will actually look, once this task is complete, Tekton chains will look through the results, looking for information around what image was built. And so we're basically giving Tekton chains a hint here where we're telling it, hey, like if you look in the results of this task, you'll see the name of the image and the digest of the image. And that way you can know what image was built by this task run. So we can apply this task to the cluster. Cool, so now it's there and we can use it. Before we go ahead and actually run this task, we need to set up a few more pieces in the cluster. So the first thing that, so we already installed Tekton chains, but I need to set up a service account in the cluster with permissions to push to ECR. So we'll need to, so I've already done this as well, but I'll show the commands. So I use the EKSCTL command line tool again to create a service account called ECR Pusher. This one lives in the default namespace in my cluster, and it basically has this Amazon EC2 container registry power user permission. And what this is going to do is it's going to allow tasks that run under the default service account to have the permission to push to ECR. So our Canico image needs this permission so that it can push the final image that we're planning on building in the task to my private registry. So I've already done that. And then the other service account that I set up is the same permission, but this time for the Tekton Chains controller service account in the Tekton Chains namespace. So the Tekton Chains controller also requires this permission because the way I've configured it, I want signatures and attestations for my final image to exist in OCI alongside the image itself. So the nice thing about that is that we can use some of the Sigstore tooling like Cosign to do our verification, and it makes it really easy for end users to verify images as well. So we have this service account as well. The final thing that I think I already did, but we will run this command just in case I didn't, is set up a Docker config, which will be mounted, a config map, which will be mounted into the Canico task itself. So this is how we basically tell Canico, hey, we're running an ECR. Look where you would expect credentials for in EKS to exist, or for authentication to ECR. So I think I already did this. Okay, yeah, we already did this, so it's gonna fail. So now one last piece of setup Tekton Chains has a few different options for how you can configure different parts of chains. So you can set up different ways of signing keys. We support setting up your own key pair using a KMS system, or signing or keyless signing with a certificate authority like full CO. We have different formats that you can kind of set up attestations in, and kind of a bunch of different things that we can configure. So there are 4 things that I want to configure before we get started. So the first one is basically saying if you see a task run that's been completed, the format that I want any attestation to be in is in toto, which kind of goes along with the salsa specification. We're telling it that for task runs, we want task runs to be stored in OCI, which is why we had to set up the permissions earlier to push to OCI. And then we have a couple experimental features which allow us to integrate with some of the Sigstore services like Recore and Full CO. So the first one is we've set transparency enabled to true. So if everything goes according to plan and we're able to create a signature for the image we're going to build, it'll be stored in the Recore transparency log. And the last thing I've specified is that I want to sign with an X509 key, and I've enabled Full CO to true. So instead of having to kind of set up my own public-private key pair, I'm just going to let Tekton Chains do keyless signing with an ephemeral key pair and request a certificate from Full CO instead. So we can hit enter. I ran this already, so there's no change. And that is all the setup that we need to do in our cluster to actually, for everything to work as we expect it to work. So the final image that I want to build is going to be called this. It's just my private ECR repo. The image is called Kaneko demo. I'm just going to store that as an environment variable. So in earlier examples, we had the task run specification for the associated task in YAML, but you can actually also just start a task from the command line with the tkn task start command. So I'm going to be doing that for this example. So what this command is basically saying is we want to start the Kaneko chains task, which we already applied, use the default settings as much as we can, but there are some fields that we have to pass in ourselves. So we're going to pass in that the image that should be built is image name, which we specified earlier. We're saying that source, where the Docker file lives, we want that to start off as an empty directory. And that's going to work because the first step is going to create the Docker file for us. And then we want the Docker config to kind of be mounted in from this config map, which I created earlier called Docker config. And finally, we want the service account that this task runs under to be ECR pusher, so that we have the expected permissions we need to push the final image to OCI. So I'm going to kick this off, and it gives us handy command that we can run to track progress. And if everything goes according to plan, this should build an image and push it to my registry. So the first step was the add Docker file step, where we created the Docker file. The second step was build and push, where we actually ran Kaneko. So you can see it's kind of going through the Docker file that we built and building the image, and then it pushed it to my final destination. And the last step, write URL, just kind of prints out the name of the image that we built once again. So we can take a look at this task run now that it's been completed with the tkn command, and just kind of take a look at what happened. So there's a little bit more information in here, which is interesting to see. We have the params that we specified when we started the task, the final results of this task, which are the digest and the URL of the image that was built, and it gives a little information about the workspaces and the different steps that were run. So now that this task run has completed successfully, this is where kind of Tekton Chains comes into play. So we have Tekton Chains running in the Tekton Chains namespace, and really similarly, it's just one controller. And basically what Chains is kind of always doing is it's always observing all of the task runs in your cluster. And when it sees that a task run has completed, it'll go and it'll inspect the task run to see if it has created an artifact that Chains kind of is aware of. So one of those artifacts is an OCI image. So like I mentioned earlier, the results that we set up in the Kaneko task kind of hint to Tekton that an image was built. And so Tekton is going to go into that task run, see that image was built, and try to sign it in the configuration that we set up. It's also going to try and generate signed provenance for that image and store that in OCI as well. So we can take a look at the task run itself. We have had a few running. Let's take a look at the Canico one. And the way that, and what Tekton Chains will do is it will kind of append some annotations onto the task run if it was successful. So Chains already took care of the signing for us. We didn't have to do anything. And it has marked that the task run has been signed as true. And it also shows us like the entry in the record transparency log where things are stored. So what does this kind of get us? Say I'm an end user and I want to run this image now. Let me actually get the details of this image again. So the first thing I can do is I can pull down this image and I can run it. Hopefully, I might have actually forgotten to set up off for this. Ooh, yeah, I forgot to set up off. Give me 1 second. Okay, let's see if this works now. Great. And we can see that we ran the image and we got the hello world output that we were expecting. So I'm an end user. I've downloaded this image, but now I have some questions about it. Like, do I trust this image? Like, how was it built? Do I know anything about it? And so this is kind of where all the Tekton chain stuff that we set up earlier gets really useful. So we can use cosign, which is the Sigstore tool for signing and verifying containers and other artifacts as well. And we can just run a quick cosign verify on this image name. I've already forgotten this image name. Let's do it like this. We're going to turn on the experimental feature so that cosign can kind of search through the record transparency log for information about this image. So if we run just cosign verify on this image, we can see that the verification is successful, that there were signatures present in OCI and the verification worked. And we can also take a look at the payload that the signatures signed over. And you can see that the signature includes the name of the image, the digest related to the image, and it also shows that this certificate that was issued for this signature was issued by my EKS cluster, which is really cool. And we can see that the subject is the Tekton Chains controller service account. So we kind of have an idea that this was built by Tekton Chains and it was built in my cluster, which is really cool. So now you might be asking, like, what else, kind of what other information can I find out about this image? So we can also look at the attestation that Tekton Chains produced for this image. So the first thing we can do is actually verify the attestation, make sure that it was signed. And if it was signed, then we kind of have some more confidence that it is correct. So similarly to above, we can see that the certificate subject was my Tekton Chains controller service account and that it was issued from EKS, from my EKS cluster. And then this is kind of the payload that was signed over. So there's a lot of information in here. I will actually go through Record to kind of show the attestation itself. So as an end user, if I have this image and I know the digest, I can also find all related entries in the transparency log with the Record CLI command. So I can do a Record CLI search and then search by the SHA-256 digest of this image. And we have one entry, which we just created. So if I get this entry by UUID, you can see there's some information about this image in here. So we have the actual attestation that was generated. This is the certificate that was issued. And we can take a look at some of this stuff. There's a lot of encoding and decoding in this work. Oh, I did something wrong. Cool. Cool. And so we can see that the attestation for the image exists in the transparency log, and we already verified that it was signed. So we can kind of feel a little more confident that it's correct. But there's a lot of interesting stuff in this attestation. So the attestation is in the in toto format, which we had earlier in forms chains that we wanted to do it that way. We can see that the subject is the image itself with the digest associated. And there's some useful information in here. So all the parameters that we had set in our task run, we can see here. And there's this field called build config, which basically shows all the steps that were run that went into building this final image. So the cool thing about this is if somebody wanted to recreate this image and kind of see how it was built, they could do that from the information in this attestation. There's a little bit of metadata about when the build started and when the build finished. But yeah, that's pretty much the attestation that we have in Recor. And then we can also take a look at the certificate that was issued. Which is in here. Cool. And then can decode this again, type it into JQ. What did I do? It's a certificate. Yeah, so this is a certificate that was issued by Fulcio for the image that we signed. So yeah, that's pretty much my quick demo of using Tekton on EKS and how you can kind of use Tekton chains to get built-in integration with Sigstore for all of your like signing needs.
Yes, that's awesome. Awesome. That's wonderful. Like, I really like your passion of doing, like, I'm really nervous when I do live coding with it, but really like the stuff. And you talk about wonderful project like Conico, Tekton chains. Tell us about more the Tekton chain, like how one of the use cases that you draw wonderfully. But tell us about what Tekton chain is, how you can use it in some of the supply chain security stuff.
Sure. So a lot of it is kind of what I said before. So Tekton Chains is really meant to be run alongside Tekton. It's not going to be really useful unless you are already running Tekton and running Tekton builds. But the idea behind Chains was for people who already have Tekton builds running. We wanted to make it as easy for them as possible to add some more security into their existing Tekton pipeline. And so the idea was like, there'll be a little bit of initial setup, but once that setup is done, Tekton chains will just run and take care of everything, and people won't have to think about it. Like after that, like they won't have to think about how to sign their images, how to generate provenance, where to put it. It's kind of just like a one-time setup, and then every build that runs in that cluster will be signed and will have like provenance generated for it automatically. And we use a lot of the Sigstore tooling. We pretty much use all of it because we have support for getting certificates from Fulcio, storing things in transparency logs. And we've done it so that it's really easy to verify everything from cosign. So all users need is kind of the name and digest of an image, and they can get tons of information about it if it's been stored in the log.
Absolutely, absolutely. And another thing, like, tell us about what cloud native CI/CD is. Well, we've been known the what the CI/CD, but the what your suggestion was for the people who are building CI/CD pipeline on top of cloud native. What should they do? Like, we have a wonderful solution, like I think we have two solution in the currently in the market, Tekton and Argo Flows, that
Mhm.
do the cloud native CI/CD. But I think a lot of the misconception in the people mind, what does the cloud native CI/CD mean? And can you draw some point to people who are watching or listening to us? How should they implement the cloud native CI/CD?
I guess it's hard to say because there's like so many different tools out there and they meet so many like different use cases. So I can't really like I guess I have only very broad advice, which would be like check out the different projects and kind of see which one fits best with your needs. Um, I'm the most familiar with Tekton, so I can talk about that, but I'm not as familiar with some of the other like cloud native CI/CD projects, so can't really speak to them. Um, but if you're looking at it from a security angle, I would say definitely like take a look at the salsa levels, figure out what like level of security you're comfortable with, and then make sure that the platform that you're running on can achieve that level.
Yes, absolutely, absolutely.
Mhm.
And final question from my side is from like Tekton is really easier to use. Like like you show the step, it's at task, then you have a parallel pipelines in it, and you
Mhm.
can draw have you have templates like pre-built you can use pre-built up template for the task itself. It's been a wonderful tool. And you have during the conversation talk about some Conico, and that is
Mhm.
really one of my favorite tools at this
Oh,
moment
cool.
of time. So tell us about the Conical and why people should looking at it, the Conical.
Totally.
It,
Um, Kaneko was actually my first project at Google. Yeah, it was the first code I ever really wrote that people actually used. So it has like a special place in my heart for sure. Um, but Kaneko, yeah, it's an open source project. It's a tool to make it easy to build images from a Docker file in Kubernetes because a lot of time you don't want to give Docker the permissions required to actually run in your cluster or to be mounted into your pods. Um, so that's pretty much the basic thing. If you have a Docker file and you want to build it in a cluster, use Kaneko. Um, I have some ideas around kind of adding some of these security features to Kaneko itself in the coming months. I think it would be really cool if Kaneko could generate SBOMs or assign images for you as well, like once they've been built. Yeah, keep an eye out. It would be cool.
yes, absolutely. Why we definitely collaborate on that part as well. We can do another session on that Conico as well because it's getting a lot of attraction these days. And
Mhm.
also one of the Walid is also is on the chat and he's talking about so Tekton is a product or a platform. Can I say IBM, Google, and OpenShift Tekton implementation can be considered the same? So, do you tackle that question?
Um, well, I guess Tekton is like an open source platform, and then you would run your builds on top of it. In terms of like IBM, Google, and OpenShift, I actually don't know. I mean, I would assume that like if they're using just kind of like the open source version of Tekton and making no modifications, then yes, they can be considered the same, and you can probably do all of this. You can run the same pipelines across all three. But if they are making any sort of special modifications to the code, you'd have to look into that.
Absolutely. And before I let you go, tell us about Cosine and other Project Sigstore rating. What's coming up next? Because it's really hard and looking at the news and features and versions and supply chain. There is so difficult to look at this landscape. So what's is coming up? What's in the pipeline? What's in the roadmap for the Cosine, Recall, Fusia, other tools?
Totally. So, the past month, I've been working on this Sigstore GA effort so that we can get the public instances of Recore and Fulcio to general availability. And the idea is that once they are generally available, people can kind of rely on them with and have faith that they'll be up and they'll be running and that there won't be any breaking API changes. Um, and once that's done, we can sort of take using those features out of the experimental category in tools like Tekton Chains or Cosine. So right now, it's not so much new features, but we're looking for a lot more stability and kind of a lot more confidence that these services aren't going to disappear or break anytime soon. So and hopefully once that's done, people will kind of feel more confident to start using them and experimenting with them a little bit more.
Absolutely. Yes, absolutely. Absolutely. And a lot of the folks joining in, and we have a very cool eye on it that it's this team brings one security is as easy as it would be for all of us who are really shy at implementing the security container security before. So I learned
Mm-hmm.
wonderful things during the whole conversation and hope to catch up you again some other projects. And you've got a wonderful team, so I will keep an eye out on you of what's coming up in the chain guard team. So thank you very much for joining me on this podcast. Hope to catch up you again in the future. Stay safe, stay happy, and I think it's been another member from the Sigstore. So Sigstore GA Live. Wonderful, wonderful, Pariko. Then thank you very much for joining us, everyone, on the podcast. Hope to catch up you again in the future. Stay safe, stay healthy. Bye bye, everyone, and we will meet you again in the next episode.